All right, we're going to do problems 1 through 5 on review day 2. The first one says a particle moves on the x-axis, so its position is given by this, and we want to know when is the velocity first equal to 0. So this is a position function, so to get velocity we're going to have to take the derivative of that. So because it's this times this, we're going to do a product rule. So it's going to be the derivative of the first, which is 12 times derivative of e repeats itself, then times the derivative of the exponent, which is a -1, so I'm going to put a negative right there, times the sine function as is, okay? And then plus, now we leave the first function alone, and we do the times the derivative of sine, which is cosine, okay? So that was product rule. If you had that to start with, that's good. Now we want to know when does that equal 0 for the first time. Something that would be really helpful for you to do is to see that you can pull a 12 and an e to the negative t out of all of this. And that'll leave you with negative sine t plus cosine t. Now, e being a positive number will never equal 0, so this right here can never give us a 0. The only thing that could give us 0 is right in here. So we want to know when does negative sine plus cosine, or when does cosine minus sine equal 0? Or in other words, when does cosine equal sine? And if they're adjacent over hypotenuse, opposite over hypotenuse, adjacent and opposite are equal at 45 degrees or at pi over 4. And so we end up with pi over 4 as our answer to that one. All right. Yeah, a little tricky. You can definitely get the derivative, but if you don't see that part there, it can throw you off for sure. All right. Our second one says that f is given as this accumulating function here, and we want to know what is the expression for f prime. So if we take the derivative of f, we're taking the derivative of this integral, and we've been saying that anytime you take the derivative of an integral, it's just going to cancel, and you do just a simple little replacement. Now you can overthink this one because of the -1 and think, well, the derivative of 1 is 0, but that's not what we're doing in here. We're not taking the derivative of these things. We're just replacing the t's with x's and leaving everything else alone. So the answer on this one was D. So actually it was a pretty simple one if you just did the process that you were supposed to there. Okay. Number 19 here says that we've given a function and we're asked to approximate f of 1.5 using the tangent line at x equal pi over 2. So anytime we see tangent line, we got to right away think point and slope. All right, so our point we were given as pi over 2. We were not given the y coordinate, so we have to figure that out. So f of pi over 2 is 2 times cosine pi over 2 plus 1. Cosine of pi over 2 is 1. 2 times 1 plus 1 would give us 3. So that's our y coordinate. Okay. As far as the slope goes, now we've got to take the derivative. So the derivative of this function is 2 times derivative of cosine, which is negative sine. So we're going to get negative 2 sine x, and then the derivative of 1 is 0. Now I want the derivative at pi over 2. So that's going to be negative 2 times sine of pi over 2. And the sine of pi over 2 is 1. Negative 2 times 1 is negative 2. Now, as I'm doing that, I've just realized that I've told you that the cosine of pi over 2 and sine of pi over 2 is 1. So I'm wrong here, right? Cosine of pi over 2 is actually 0. So this actually is 1. Glad I caught it now, right? So there's our line. We can make that tangent line now. Y minus 1 equals negative 2 times x minus pi over 2. That's tricky enough, but then they want us to use it to approximate f of 1.5. So whenever we do an approximation, we're just throwing that number right in there for x. So y minus 1 equals negative 2 times 1.5, which I'm going to write as 3/2 on purpose, because now I'll have y minus 1 equals negative 2 times 3 minus pi over 2. When I multiply, these 2's will cancel, and this negative then will distribute. So I'll get y minus 1 equals pi minus 3. And then if I add 1 over, I'll get pi minus 2, which was C. Okay, So definitely, just even the equation itself is tricky enough, but then using it after that can be a little bit cumbersome. So you just got to be real careful as you go through that. Number 4 here says that if f is equal to natural log of x, then what does this equal? Now, if you put 3 in, you get 0 over 0, which again kind of tells you to do L'Hopital's rule, and that wouldn't be a bad idea. L'Hopital would say, take the derivative of your function. So the derivative of our function would be 1 over x. F of 3 is a number, so the derivative will be 0. Derivative of x is 1. Derivative of that is 0. So really, L'Hopital would take you to 1 over x. And we're going to do the limit of that as x approaches 3. So we end up with 1/3. So that one, again, straightforward as long as you don't overthink it or try to overdo it. Okay. Then our last one here gives us the differential equation and says if y equals 0, which of the following would be this? I think we actually had this one on the worksheet from the other day. So I'll just go through it again real quick. We want to divide by y, so dy over y equals 2 over 2x plus 1 dx. We're going to integrate now, so the integral of this will go to natural log y. If you do a u sub or just see that the derivative of this is right up there, you'll see that this also goes to natural log 2x plus 1 plus c. We're going to put 0 in for x, which gives us natural log of 1, which is 0. So just c there. Put e in for y, the natural log of e is 1. So we're going to put 1 in right there. Natural log y equals natural log 2x plus 1 plus 1. We're going to raise it to the power of e. So e to the natural log. And this 2x plus 1, because of the condition they gave us, will always be positive. So we don't really have to have the absolute value there. And then because of this plus 1, we could separate that into e to the first power. Now I've got e to the natural log. That's going to cancel. Give me 2x plus 1 times e. And if you distribute that, you end up with b as your solution.